All right, so let's finish up yesterday's lesson, okay? This just asked you to factor and simplify. So we were simplifying rational expressions. So in E and 5, I don't know why we kind of mix them up, but hey, such is life, okay? So what I want to do is I want to factor the numerator. I look at the numerator and I see that they both share an x, Julia. You notice that too? So I'm going to factor that out. It gives me x times the quantity of x squared minus 16. I'm also kind of feeling that x squared minus 16 can also be factored. Gut intuition. All right. All right. I'm thinking in my head right now, what are the factors of 16 that can give me 0? I think we already know that. On bottom, I'm looking for the factors of -8 that add up to -2. I'm thinking x minus 4 times x plus 2. So far, so good. Now, there's nothing I can simplify here because I did not factor that x squared minus 16. What are the factors of -16 that add up to 0? 4 and -4, right? So we have x plus 4 and x minus 4. And that's nice because on bottom, we have an x minus 4. So here, I cancel those out. And I have x times x plus 4 in the numerator and x plus 2 in the denominator. Kaylin, how do you feel? Pretty good about this stuff? Mike? In Spanish, más o menos? I thought it was spicy minnows for like literally 2 weeks when I was in Costa Rica. And I would just walk around and be like, spicy minnows. And then it just became like an Italian accent. So I'd be like, spicy minnows. And they're like, okay, cool. 2 weeks. Más o menos, like more or less, but spicy minnows. All right, number 5 kind of has the same vibes as E. So I'm going to factor out that x leaves you with x squared minus 4. On bottom, I'm looking at the factors of 6 that add up to -5. I immediately think to myself 2 and 3. Okay, that's what I'm looking at. So I have x minus 2, x minus 3. Do you guys feel like you're getting this, like the factoring more? Like you just start to see them? Okay, they just kind of like pop out. Like at the start, you're like writing that list, but now you're like, 6, -5, 2 and 3. So that's where we're supposed to get to. It's just that feeling where we can just kind of get that gut feeling that it's going to be -2 and -3. So the numerator is going to factor the factors of -4 that add up to 0. I think Ms. Puckett's probably like, why are we asking this? We all know it's 2 and -2, Harmon. Let's just move on with the lesson. Okay, so we have x plus 2 times x minus 2. And then on bottom, we have x minus 2 and x minus 3. And Franklin. Franklin.
Yeah.
What's the same on top and bottom?
X minus 2 and x minus 3.
X minus 2, very good. So we're going to cancel those. So I have x times x plus 2 on top and x minus 3 on bottom. All right, now I don't shy away from a challenge, unlike Lance, who's shying away from my race. He doesn't want it. Anytime?
Yeah.
All right, when? You said anytime. When? I don't know, what's your mile time? Yeah, I know. What's your mile time? Huh. Mine's like 7:04. Sometimes it's like 6:58, when the wind's blowing in my face. So I'm feeling pretty good about myself. Yeah, that's why it was 7:04. 6:58 if it's, back half of the track. Maybe we could sell tickets to a fundraiser. Okay, maybe. Okay. You have to sign a waiver, because I don't want you to like complain when I beat you in a race. All right, so not going to shy away from the challenge. Okay. The numerator, that one kind of seems funky to me. More funky than the denominator. Okay. I'll tell you why the denominator is not something to be scared about. All right. So let's deal with the numerator first. The numerator, we got to do the British method, right? So I'm thinking 2 times -5, that's -10. I'm trying to think to myself, what are the factors of -10 that add up to 3? 5 and -2. So I am going to rewrite the numerator as 2x squared minus 2x plus 5x minus 5. Again, I did 2 times -5. That was -10. What are the factors of -10 that add up to 3? Notice right there. Okay. Again, I'm still not dealing with the denominator yet, just working with the numerator. I'm going to factor out a -2, or sorry, not -2. Let's just factor out a 2 from that. So if I factor out a 2 and an x, that's going to leave me with x minus 1. And then I'm going to factor out a 5. That also leaves me with x minus 1. Again, I'm still pretending that the denominator doesn't exist right now. And then I notice they both share an x minus 1. And I'm going to write what's left. It's 2x plus 5. So I'm feeling pretty good. Now, the denominator. You guys are probably looking at the denominator and thinking like, whoa, we have 7 minus 6x minus x squared. And I haven't taught you how to deal with the minus x squared. Have I? No. But I have taught you how to factor. Watch this. Well, there is no rule that says I can't factor out a -1. Watch what happens when I factor out a -1. 7 divided by -1 is -7. -6 divided by -1 is +6. Negative x squared divided by -1 is positive x squared. Well, look what that did. It just flipped my signs. And if I rewrite that with x squared first, see? It's pretty simple, right? What are the factors of -7 that add up to +6? X minus 1, x plus 7. And we can see those cancel. All right, so whenever you have a negative, I guess, leading coefficient, so to say, that number in front of x squared or whatever is negative, you can always factor out a -1. And all it does is flip your signs. And the one thing I have to be careful about is not forgetting about the -1 in the answer. That's the only thing that happens. All right. Yeah, I'll do this one. I feel like doing a word problem. It says find the ratio of the shaded portion to the total area of the figure. Okay, so we're talking about areas, so we're talking about length times width. Okay, I just have to make sure I put it in the right order. it says the total area and the sheeted area. So sheeted area is going to be on top, total is going to be on bottom. So on top, I have x times x plus 1. Do yourself a favor. When you are dealing with rational functions, do not multiply things out unless you have to. Okay? If you start to multiply things out, remember the end result is something, we're trying to cancel things on the top and the bottom. So if I multiply x times x and x times 1, eventually I might have to factor that, and that's gonna like double my work. So leave it like this. Now on bottom, okay, we have the total area, that's x plus 1 times x plus 3. Do you see why I said don't multiply it out? Because now you can easily see that the x plus 1's cancel. And your answer is just x over x plus 3. All right. Now, that little bit of advice I gave you was crucial to 6.2. So this is the start of 6.2. Here's the thing with 6.2. Don't multiply things out. Cancel first and then multiply. Okay? Here's why. Okay? If I start to, I guess, multiply things out, kind of like what they did here. Notice they did 3 times 7 is 21 and 4 times 6 is 24. Well, then they had to break 21 up into 3 times 7. And then they break 24 up into 3 times 8. And they canceled those, correct? Instead of doing that, if I look here at 3/4 times 7/6, I can see 3 goes into 6 2 times. Right? And I can do 1 times 7 is 7, and 4 times 2 is 8. And I know it seems kind of like, well, that wasn't so hard. But when I'm talking about these things, all right, it can kind of get crazy. Now, monomials, dealing with multiplication and division, not a big deal, right? It's not a big deal because I'm not just dealing with distributive property and all of these other things and factoring. So it kind of doesn't hurt you in these problems, but this is where things are going to get crazy. Okay? So here, what I want to get used to doing, and I'm going to zoom in so we can all see this. All right, I think that's a little better. What I want to do here is I want to start canceling now in this form. All right, and kind of like be comfortable with it. So here, 5 goes into 10 2 times, and 5 became a 1. We okay with that? 2 goes into 6 3 times. You guys see what I'm doing here? All right. Now, can my numbers, can I reduce them anymore? No. 1 times 3 is 3. 1 times 2 is 2. 3 and 2, we'd like to say are co-prime. They don't share any factors. So I have 3 over 2. Those are my numbers. X's. All right. I have 1 x on bottom. That's going to cancel with one of the x's on top. I don't have any more x's. So I have x to the first, x to the third. That's x to the fourth. Y's. All right. Here, all right, let's kind of look at this. I have 1 y here, 1 y here. They cancel. Y squared, well, that's going to cancel completely with 2 of these. So I'm left with 1 there. My answer is just 3x to the fourth over 2y. You guys all right with that? Okay. I like canceling at this stage because I'm doing the problem. Because I know whatever I'm writing here, it's going to be done. I've already done all the canceling. The other way to do these problems, which I'm not a big fan of, but I'll show it to you anyway. 6 times 10 is 60. X squared, x to the third is x to the fifth. Y to the third, y to the fourth is y to the seventh. 2 times 18 is 36. X squared, that's it for the x's. Y squared, that's y to the fourth. And now here, now you have to reduce. What are the factors that go into 60 and 36? All right. First thing I saw, I'm not gonna lie, 6, right? That was the first thing I saw. I think we all saw it, right? All right, I don't think anybody saw 12. Okay, so 6, 10, and 6. I'm like, oh crap, well, got to do another line. The x's, x to the fifth over x to the squared, it's x to the third. Y to the seventh over y to the fourth, that's y to the third. Okay. The variables are a little bit easier to deal with here, but I feel the numbers aren't. And then you see 10 over 6, take a 2 out, it's 5 over 3, x to the third, y to the third. I'm okay with either way doing this. I just know where this is going, and I try to like give you a warning. All right, so this is fine for monomials. Multiplying it out, I like to cancel as I go along, either or. All right, I want you guys to try. Well, I don't know. Let's put. Lance said his mile time was 8 minutes, so we're gonna put 8 there. And add like x squared there. Yeah, there we go. That looks about right. Thought about putting 1 there because I feel Lance is going to show up to the race with 1 shoe, and not 2. 3? You plan on losing 1? Always come prepared. All right. Why don't you guys try 1 and 2, see if you can get it done? 3 pairs of shoes. Let me see you're actually like nice spikes. Oh, Ross, that's pretty nice. Nice. Size are you? All right. Wind resistant. Nice little collection there. There's people. It's going to cause the shoelaces to break in the middle of our race. 8 points. Just remember, all this is on YouTube. So if you ever want to like go back and revisit this conversation, you can. Forever. Never. I'm not taking it down. It's on YouTube. Live stream. You know, I have like 3 followers. Not one of which is you. All right. So if I'm doing number 1, I like to kind of cancel as I go along. 8 goes into 32 4 times. 6 and 9. 3 goes into 6 2 times, 3 goes into 9 3 times. All right. Then I'm kind of feeling, oh, 2 and 4. 2 goes into 2 1 time, 2 goes into 4 2 times. So I have 1 times 1, that's 1. 3 times 2, that's 6. Okay. I understand my way can be a little confusing, but you can choose your battles. Okay. This s and that s, they cancel. S cubed, s squared. Well, the 3 becomes a 2. That s gets canceled. So I have 1s squared over 6. All right. Down here, 4 goes into 8 2 times. So we're left with 1 there. 15 Well, in 18, 3 goes into both of them, so we have 6 and 5. Now I notice here, 2 goes into 2 one time, 2 goes into 6 3 times. So I'm left with 3/5. In terms of x's, well, I have x to the 4th on top, x squared, so that cancels. The 4 now becomes a 2. This x cancels with one of these, so that's a 1, so it's just 3x/5. Guys doing all right with them? Okay. I actually like these problems less than the next problems. These problems are just annoying to me. But let's look here. All right. Now I'm not going to get through a ton of this stuff, but I do want to show you why I said don't multiply out. Okay? Do not copy this down. This is why you do not multiply it out. So in A, if I were to just kind of multiply it out, okay? All right, I'm kind of multiplying these things. So I do like the 4x times x squared, we get 4x cubed. And then that. So we get plus 4x squared. And then that times that. I get negative 24x. And then I got to do this. Oh boy. So I get negative 4x to the 4th minus 4x cubed plus 24x squared. On bottom, well, I have to multiply this by this. And that gives me 4x cubed plus 8x squared minus 12x. All right, this would cancel with that. All right, so that leaves me with negative 4x to the 4th plus 28x squared minus 24x all over 4x cubed plus 8x squared minus 12x. And now you have to cancel stuff, right? How do you factor that? You can't, right? I mean, it like, yeah, I could cancel out x, right? They all share x's, I could pull that out, but then I have a cube, and where do you go from there? So that's why I said don't multiply them out. It leads to nowhere. It's a bunch of wasted time and a lot of headaches. All right. So here's how you tackle these problems. So what you want to do is you want to factor things first. You don't want to deal with multiplication yet. You want to cancel out the like terms. It seems kind of counterintuitive because we've been taught for years that simplification is like multiplying and combining like terms. But in reality, when you get higher in math, okay, it doesn't really matter to me. Okay, I like to see things broken down, okay, into its components. So what I want to do, and this, please copy down, okay? What I want to do is I want to view this as 4 kind of different factoring problems, okay? Let's look at this piece here first, in the top left. 4x minus 4x squared. What does that have in common? Well, it has in common a 4 and an x. So I'm going to factor out 4x from that. So this is, I have 4 colors, so I'm going to use all 4 to break it down for you. So this is my blue equation, or my blue expression. So I factor out a 4, that leaves me with a 1 minus x. Is everybody following me how I got that? Pull out a 4, 4 divided by 4 is 1, x divided by x is 1, so I have 1. 4 divided by 4, that's 1. X squared divided by x, that's x, so it's 1 minus x. All right. This green piece right here. What are the factors of -6 that add up to 1? X plus 3, x minus 2. All right. Down here, what are the factors of -3 that add up to 2? X plus 3, x minus 1. And the last little bit, that can I do anything with it? And the answer is no. Now that I've broken it down into its parts, well, Kailana, what do you say? All right, hold on. There are 2 4x's. These cancel. Very good. Mike, what else do you see? Anything the same on top and on bottom? Yeah, the x plus 3's, they cancel. Hannah. What else? Are you there?
Yeah, wait, what?
What else is like the same?
Oh, the 1 minus x and the x minus 1.
Now, you are correct, but here's why you're correct. Now, you want to cancel them out, but I can tell by the look on some of your faces, you're like, "Oh, they're not the same," but they are. Watch. 1 minus x is almost what I want it to be, right? I want it to look like x minus 1. So how can I do that? Well, remember, I said my leading coefficient, whenever it's negative, I can factor out a what? -1. So instead of dealing with it as 1 minus x, I can factor out a -1 from this. Okay, I'm going to pull out a -1, and then I'm going to rewrite that as -1 times x minus 1. Notice if I were to distribute that -1, -1 times x is -x. -1 times -1 is +1. Now I can cancel x minus 1 and the x minus 1. So this whole problem boils down to -1, okay, times x minus 2, which doesn't bother me if you leave it that way, or if you were to write it as 2 minus x. Do you guys see that? Do you see the importance of factoring first and reducing first, then multiplying it out? Look at the difference of our 2 problems, right? I got to a point I was like, not quite sure where to go from here. Whereas this whole thing boiled down to just 2 minus x. You okay with that? All right. I have time for B. In B, I have kind of 4 different pieces to break up. The x cannot be broken up. X minus 4 cannot be broken up. I'd like to write them in parentheses. All right, so that one. Here, this green one. 5x squared minus 20x. How's it going, Michael Floyd? Okay, I'm going to factor out a 5x. 5x squared divided by 5x is x. Negative 20x divided by 5x is -4. So I have x minus 4. Okay. 2x squared plus x minus 3. 2 times -3. All right, we're doing it the British method. It's going to be -6. What are the factors of -6? That add up to 1. So I'm going to write 2x squared, and then I'm going to write minus 2x plus 3x minus 3. I'm going to factor out the 2x. That leaves me with x minus 1. Then I'm going to factor out a 3. And that leaves me with x minus 1. So this boils down to 2x plus 3 times x minus 1. And now I'm looking at this and I'm saying, what can cancel? Well, we have x minus 4 and x minus 4. We have the x and the x. So I have 1 left on top because there was nothing left. And on bottom, I have 5 times 2x plus 3 times x minus 1. And that's that. All right. And we're going to call that a day.